All right, the next part of this lab involves using paper. Instead of using newspaper, I'm going to use printer paper because I could measure the thickness of it, as you can see on the lab handout here, the revised one. I measured 5.2 centimeters for a 500-page thickness using both calipers and a ruler. And so from that, you can figure out how thick an individual piece of paper is. And don't forget that you need that in order to determine the spacing between the two plates of the capacitor. That's your little d. Now on top of this bottom plate, which is this piece of foil here, again 25 centimeters by 25 centimeters, I'm going to put my dielectric, and I'm going to make it so that it's just the thickness of that piece of paper as best I can. Try not to get any of that metal coming through to short circuit the other piece of metal that I'll put on top. That's my topmost capacitor. Once I hook it on here, hook it on right there, and you can see it's saying it's a bit bigger than it was earlier with the poster board because the paper is so much thinner, and also the dielectric constant may also be different. So I'm going to put a book on top of this to really weigh it down and avoid short-circuiting it. So here goes the book. Oh wow, we're talking like 9 point, get rid of this wire that's in between here. Notice the harder I push it down, the bigger the capacitance gets. I don't know if you can see that on here. Let's see. So we're talking, if I really push it down, I can get up to like 12 nanofarads. Significantly larger capacitance than we had earlier. All right? And if I let it go loose, you see it drops down to about 7 or 8 because the spacing increases between them. All right? So let's go with as much pressure as I can put on it here. We're talking like, whoops, probably short-circuited there. That's why oh no, this came off. You know something happens funny when you get a funny reading all of a sudden. There we go. How big can I get this? Just make 12. Something almost 11.9. Oh, I made it to 12 nanofarads. All right. So that's about the capacitance of the biggest I could get here by doing this. I bet you if I put the book on even tighter or moved it over a little bit more, let's see what I get now. Oh, I got a little bit, 13, look at that. Okay, so about 13 nanofarads. Great. Okay, now I'm going to repeat what I just did, but this time I'm going to do it with 2 sheets of paper, and then I'll go to the longer sheets of aluminum foil and repeat again. So I'm going to go here so I can see it. Oh. There we go. So I have this sheet here, and I'm cobbling a couple sheets together because the sheets aren't exactly the right size. The most important thing, though, is that I have 2 sheets of thickness between them, mostly of the paper. I'll put this other aluminum foil on top, and before I show you the reading, what do you think it's going to be if I put 2 sheets of paper in between these same 2 pieces of aluminum foil, and of course I prevent them from touching each other? That's what we're going to see now. Prevent them from touching. It's a short circuit, and I lose my capacitor. Okay, here goes. Here's the value. Put all the pressure on it I can. I saw it go up above 6 a minute ago. There we go, 6.6, 6.7, 6.75, something like that. All right, about 6.7 nanofarads is what we got with 2 sheets of paper between our 2 25-centimeter sheets of foil. I'm sorry, between our 2 25 by 25 centimeter sheets of foil. All All right, now you get to watch me do this with two 25 by 50 centimeter sheets of foil. What do you think the capacitance is going to be now with just one sheet of paper between them? And if you said we're going to get a new record in our capacitance for this experiment, you'd be on the right track. This should be the biggest we've seen yet. Let's see if that's the case. So I'm going to hook up the bottom sheet here. I'm going to layer this paper here. If I don't get any shorts, put this here, put that there. The other piece of aluminum foil on top. Take my other probe, put it here. Okay, we're already seeing something interesting happening. It's about 0.8 nanofarads. As I spread it out and push it down, it gets greater and greater. Hopefully you can see that. I'm going to grab my books here. One book here. Jumped up to about 4 or something. The other book here, let's see what happens. I hope it gets big. I'm going to see a new record here coming out of this. All right, it's 14, 15, if you can see it. Oh, 32, there we go, 33 nanofarads. Is that what you might have expected? Think about it. I think it just shorted, that's why you got that. All right, that is our case with the paper. All right, it is saran wrap time. I have a piece of this very thin plastic that you put in refrigerators to cover food, and I have it between my two single plates. Let's see if we can get yet another world record for our measurements here. I'm going to put a book on top of the uppermost plate. Let's see what happens to the capacitance here. All right. I see 17, 18 nanofarads. Can I get any higher? Let's see how I can get. The highest I can get will be our record. Can I break 20? I feel like this is counting clickers or something. Over 20, look at that, 20.5. Oh, I saw it go to 21.09. So I broke 21 nanofarads by putting enough pressure on this. Now I suspect I can't get it to be 12 microns apart. You're probably going to get a much bigger capacitance if you do that. I can get it pretty close by putting some pressure on it. Up to 21 or so nanofarads is what I was able to see. Oh wow, 22, 23. 23 point, maybe I can make it to 24. 24. By putting pressure, I'm making that D get smaller and smaller and smaller. 24 nanofarads, I think, is the record I can claim right now for this. A little hard to show you this, but what I'm doing now is putting 2 pieces of saran wrap between here. Now I'm going to ask you this question. What do you think is going to happen to the capacitance when I put 2 pieces, not 1, but 2 pieces layered one on top of the other between my 2 pieces of aluminum foil? What kind of capacitance am I going to get now? Make your prediction and then watch me do it. Hopefully you're predicting that it's not going to be as large a capacitance because the D is greater, and D is in the denominator of the capacitance equation. So let's see what happens with 2 pieces of saran wrap. I'll put as much pressure as I can on this book, and we'll look at the meter reading here, and let's see what happens. See, I made it up to 23 or something when I had just 1 piece. With 2 pieces, I'm having trouble. Oh. Looks like I broke 4. Maybe I can make it to 5. Just about, oh, so close to 5. There we go. Broke 5. But I'm not coming close. I would have thought, personally, that it would have been half the capacitance. if I had twice the thickness. But keep in mind that this stuff gets all wrinkly, and it's really hard to squeeze all of that out of it. So it's more like I'm getting maybe 4 times the thickness rather than just twice the thickness as a result of the characteristics of the plastic, that it gets all wrinkly on top of itself. Okay, a couple more to go here. What I'm doing now is taking the 25 centimeter by 50 centimeter piece of aluminum foil, putting one piece of saran wrap between them, putting another piece of 25 by 50 centimeters of aluminum foil on top, and I'm going to measure the capacitance of this one. And if you think I'm going to get a world record, for this lab anyway, on capacitance, I agree with you. This should be the most we've seen yet, and I'll be thrilled if I can get it up to 50 nanofarads. I'll be lucky if I can, I'm guessing, but we're going to try. I'm going to put 2 books on here. All right, let's see what I can do. Whoops. Tore off. Put this on really well there. All right. All right, now I have time to put some pressure on, see what I can get it up to. It's not going to make it to 50. I can tell you that right away. But I am getting a world record anyway. It's at 345. I don't know if I believe that, but let me see if I can break 30. Oh, 30. Whoa, I saw it flash to 40 for a second there. Pushed so hard I knocked the meter down. What's happening here is that there's probably a little wrinkle or a couple wrinkles that I'm flattening out, then are unflattening, and I'm getting those large values very occasionally. Not quite getting it to where I might have hoped I would, but I'm certainly getting bigger values than I got earlier. I did see it flash to, I think, 40 at one point, which is pretty exciting. And right now, with a fair amount of pressure, I'm getting about 28, 29 nanofarads. Oh, 35.5. Huh. Anyway, I'm tired. Just when you thought we were done, the last thing that the lab requests is that you take 2 capacitors of your choosing and you put them in series and in parallel. I'm going to start by putting them in parallel. How do I do that? I connect the bottom plate of one to the bottom plate of the other. So I'm taking my double capacitor here that I just used, saran wrap one. It's 25 by 50 centimeters, separated by one layer of saran wrap. And the bottom, I'm going to attach to the bottom of a 25 centimeter by 25 centimeter piece of foil, and the top to a 25 centimeter by 25 centimeter piece of foil. Okay, so the bottom to the bottom, the top to the top. Put a book on each one. And then connect the meter to one of the tops and one of the bottoms. And we should have the biggest capacitance we've seen yet. If I put some pressure on them, it's easily getting up into the 30 range. Yes, it might get up into the 40 range if I get lucky here. 36. All right, so certainly bigger than any one of them would have been alone. Now I want to put them in series. So to put them in series, I'm going to take the top of one, put it to the bottom of the other. Then I'm going to attach my meter to the bottom of the one that is the top attached to the other one, and then the top of the other one that has the bottom attached to it. Okay? And now the capacitance shouldn't get anywhere near as big as it had because the 2 capacitors are in series. And if I put some pressure on it here, use the series formula to see what you think it should be. I'm getting, it's the most I can get when you're in series. I'm seeing like almost, I saw it go to 10. I saw it go to a little over 10 microfarads. Got to put a lot of pressure on it to get up there though. All right, so that rounds out this lab. My goal for you is you have the measurements that I made, take the data that we collected and that is available, calculate what you think the capacitance should be in some cases, what the dielectric constant should be in some cases, based upon the data that you have, and see if the calculations come close to what you might predict based upon previous calculations and based upon your measurements of, let's say, half the capacitance area. The area of the smaller capacitor compared to the area of the larger capacitor. See what you can do with that. Good luck with it, and I'll see you soon. Or you'll see me soon.